Yes, up to now we have seen how to create a file, right? How to model the SLD, right? How to copy the elements and what are the things to be done to interconnect with the two elements, everything. Let me share. Yes, in here we just model the simple system, right? And we just explain how to plot the graph and how to measure the values in the graph. And before plotting, what are the steps to be adapted for plotting a graph, everything. So now we can start with the general equipment modeling procedures. I think in the components, there are many components. We will be using one by one when we go inside the simulation, right? So if we discuss each and every element now means it will took a bit of time. So we can proceed with whatever we need whenever we need the component part. So at the time I will explain, and at the time we can proceed with these components explanation. And the models is nothing but, so in case the name of the models will be present, the same what it is present inside the master library here in form of, how to say, means meter. If you know the name means multimeter is there means you can place here, right? So instead of selecting from components tab, you can select from the direct models itself. So source, if you are knowing the model source 3 means you can select, right? So this is for just a simplified, once again, a simplified components. So which can act as a shortcuts for all the elements. From here also you can able to copy the components and paste here in our workspace. But for this, you want to know the components name, elements name, at what name it is present inside the master library. So like this, wind turbine, this. So everything will be present in the master library. So from the master library, how you are uh, selecting and what is the name given to this. If you know the name means you can able to select the element directly here. Yes. So now, so whenever we are starting with PSCAD, the basic element modeling, right? That is quite convenient and much easier to understand is the source modeling. Source modeling is nothing but the grid only in terms of PSCAD, in terms of they will be mentioning as source modeling, right? In PSCAD, in PSCAD, whatever the elements we are modeling, whatever the elements we are modeling, so we should do two things. One is modeling part, and the another one is validation part. So what is mean by validation means, in case if you are modeling any new model, right? Or else if you are modeling the basic source itself, let me say, with the help of source I am modeling power grid. So after modeling the source, I will be entering the inputs like a grid short circuit ratio, X by R, everything. But in our PSCAD, we cannot able to enter those things directly. Instead of that, we can able to enter the impedances only, right? R plus JX only we are going to enter here. After entering those things, for example, if my three-phase short circuit current is 50 ampere, 50 kilo ampere, right? If my three-phase short circuit current is 50 kilo ampere, then after modeling the source, right, I want to check that source whether it is capable of supplying the 50 kilo ampere when it is subjected to three-phase fault. Hope I'm clear. So in case of three-phase short circuit current is, if they are giving us 50 kilo ampere means So after modeling the source in the PSCAD, we want to do the simulation that the after the system is subjected to three-phase fault, my system must capable of supplying 50 kiloampere, right? That is the validation here. For each and every elements, there are different types of validation. For example, source, we are going to check the short circuit kiloampere. Clear? But in case if it is a transmission line or cable, let me show you. Previously, let me open something. Yes, let me. Yes, I have found that document. Let me show you. Or else in the simulation itself, we can proceed. Let me. Yes, the screen is not set. Just now I'm sharing. So this is the another document. So which in this, there are various types of sources in PSCAD. So there is not only one source. So for that, we should do some calculations, right? After that, we will be matching. Yes. Before that, let me show the sources that are present in our PSCAD. So still there are some basic options, but that will be resolved when we are going with this modeling, right? So see here, this is actually I have done some simulations. This is for just basic understanding only. So after completing the source, we will go with the transformer, transmission line or cable, unload, and we can perform a simple SMIB like system simulation. And what are the things to be observed, right? So now let me open the another case. We had already opened right in the morning itself. So how to open already? If you are created some other cases already, and if you want to open that case with the workspace means two things. One thing you can directly pull from here and you can leave it to the software. And the another one is from the file, use this open option. So in this, we have morning created, right? 10:54 a.m. So this case I'm now opening. So in order to perform new simulation, I'm opening a new case file. Let me enable grid lines. So usually it will be convenient for me. So now I want to model a source, right? I want to model a source. So in the master library, go to the master library. So from this case one, navigate to the master library upon selecting. There will be sources. Second tab is sources, right? So in this sources, what our PSCAD is, they are saying is totally three number of sources is available, right? Totally three number of source models. For AC, it is available. So what are the difference between these three is it is quite similar only. All these three are quite similar only. Let me explain where it will be getting changed. Let me show you. So this is sources tab. In this, so in this, this sources model number, if you just click on that, you will be observing three-phase voltage source model type 2, right? This is model 2, and this is model 1, and this is model 3, right? It will not be arranged in order, but their corresponding characteristics will be given here, right? Where should be used, and what are the parameters to be given as input, what should be taken as output. So if you observe precisely, there is only three model. So this, and this. Whereas the remaining all these models. So from this model, we can able to extract like this, right? From this model, we can able to extract like this. That is depending upon the location where we are using our source, right? We can able to just modify that source depending upon our requirement. That is simple. And upon modeling like that, so why we are modeling like that means, in case in some instances, frequency and voltage are the parameters to be controlled, right? So at that time, I can use this type 2 source. Why? Because here are the two parameters that can be controlled, frequency and voltage. Similarly, frequency, voltage, and phase angle if you want to control, right? Through external control, if you are controlling means. So at the time, you can use the model 1, this one, right? And the remaining, when you are using with the, sorry, when you are using with this model 3, so this is the actual model what we are using in our real-time project cases also. Why? Because this will give the among these sources, my this source model 3 source alone will be provide the capability of entering positive and zero sequence impedances, whereas the remaining won't. Let me show you. I think let me show that. So before that, let me open the grid data, right? See here. First, let me copy this. Let me go with model 1 first. Control C, Control V. So this is my model 1. Let me rotate this. So if you just go inside and explore means source name. So this name you can give, it is for your sake only, right? So this name won't appear in the outside of the element. Usually for most of the elements, except very few elements, if you are entering the name, it won't appear in the PSCAD, right? For that, specialized tools are there. Let me show next. See, there are various types of sources. Only R, source impedance type. R, L, R is parallel with L. R is series with R is parallel with L. So now this configuration is selected. So now it is looking like this. After that, see source control. There are two things, fixed, external, auto. If I give fixed means, see now my source, how it is looking like. It is looking like this, right? So actually the source model is the one, only one source model only. So depending upon the nature, so if now I want see zero sequence differs from positive sequence, no. If I am providing yes, ground, I think it is gone beyond this. Now the model which is placed in the master library will appear this like. The same, if it is alone, resistance alone means this will be appearing like this. See, zero sequence, yes, only resistance. Now check. So this model is shown here, right? So these three are the same. Using this model itself, we can able to change the mode of the sources depending upon our requirement. The same in case for type 2 also. This is type, the middle one is type 1, right? It is type 2. If you go inside this, there will be, it is showing model 1, model 2. This is model 3. So now I am selected model 2. So in the model 2, the factor is only frequency and the voltage alone are the factors to be controlled here. Can be controlled here. See the impedance, resistance. And before that, I want to mention one thing, right? Resistance, internal impedance. See here, only positive sequence RRL, zero sequence impedance, zero sequence RRL. So depending upon the element what you are selecting, that alone it can be enabled here. But usually our impedance is R plus JX, right? So that like we cannot able to enter only R when parallel with RL. Sorry, R is series with RL parallel. So only those configurations can be entered here. See here, R, L, R is parallel with L, R is series with R is parallel with L. For these alone, you can able to enter the impedance, not for the impedance. Z equal to R plus JX format, we cannot able to enter. In here also the same. See the configuration, resistive, RRLC, RLC. So if you are selecting, depending upon that, this factor will be changing, RLC. Right? The mode which we are selecting, for that our source will act. Clear? Usually these two types of sources we won't use. Instead of that, we will always use, even in real-time case studies also, right? We will be using this type 3 only. What is the specialized feature in type 3? Without unbeing this type 1 and type 2 model 1 and model 2 means, see here upon going inside, you can enter the positive sequence impedance here, resistance and reactance. Even in rectangular form or polar form, you can enter in both the forms here. The same for zero sequence. Zero sequence here it is differs from positive. Yes. See here. So this is the specialized feature and making us to use this model 3 source under every cases. Clear? So now let me clear these two. Just delete. So this source I'm going to use. Before that one comparison is there. Let me show you. So three-phase view also there. So this is actually single-phase view. See here. Graphics displays there, no? If I select a three-phase view, for each and every phase, we can able to connect the same source. Right? So now, let me give us a single line. Let us see the comparison first. So these are different representation. So district features, if you want to check me, this is model 1, model 2, model 3. Can input zero sequence impedance, automatic voltage and power control. Signal parameters can be behind the source or at the terminals. Controlled through either fixed internal parameters or variable external signals. Right? Whereas this model 2 is signal parameters can be behind the source or at the terminals, controlled through either the same only. When coming to model 3, it is the combination of model 1 and 2. Right? Model 1 and 2 can input positive and zero sequence impedance. Right? Controlled by external signals only. Source impedance can be entered in the format of rectangular or polar form. In other sources, it cannot be entered. Right? So here it is positive sequence impedance alone, RRL, zero sequence impedance alone, RRL. Or else just R, L. So like that individual elements capability only in these sources you can able to enter. But here, even if it is a infinite bus also, we can able to enter the positive and zero sequence impedance here. Clear? Here the external controls is, as I mentioned before, type 1, voltage, frequency and phase angle can be controlled. Type 2, voltage and frequency alone can be controlled. Whereas in the type 3 only, voltage and phase angle can be controlled. Clear? So this comparison, let me just paste in our sheet for your reference. Or else another thing. Source alone, let me create a separate sheet. So this tab is for completely source modeling. I will upload this book also. Clear? So other than this won't hold any data, right? This one we are going to see the calculations, everything. This is loads. Okay. Let me close this. So yes, now the source model is selected. Now want to model this in detail, right? So for modeling this in detail, let me choose some parameters, right? Grid parameters. Actually, I'm taking this data from a real-time project. If you're having data means you can try by yourself. So upon taking in a real-time project, I'm in a situation that I cannot able to present that everything. So I will just mention the values, right? So first one is voltage. Usually voltage means line to line only. Then frequency. Then three-phase short circuit current. Three-phase short circuit current. Then single-phase short circuit current. Then X by R three-phase. X by R ratio three-phase. Then for single-phase also, there will be different X by R. More, in rare cases only, it will be similar. Right? So voltages, it is actually a 230 kV system and my frequency is 50. In here, my both the short circuit current, a single phase and three phase are the same. The X-fire ratio for three phase is 72.82, whereas for single phase is 54.93. Clear? So this is kV. It's kiloampere. Kiloampere. Clear? So for our calculation, in some cases, we need line to ground RMS also. We need line to ground RMS also. Then I will be just simply 230 divided by square root of 3. So 132.7906 is there. Yes. Now after that, in simple terms, in E tab, we can able to enter this four things alone, right? Three-phase short circuit current, three-phase X by R, single-phase short circuit current, single-phase X by R. So upon entering this itself, our theta will automatically calculate. But in case of PSCAD, it won't do like this. See, let me explore this. Going inside, usually how to check with the PSCADs means, first of all, whatever may be the element you are selecting, there will be two halves. One is left half and the other one is right half. The left half will be having different sections, right? The left half will be having different sections. See, here it is having four sections, right? How it is having four sections: configuration, positive sequence, zero sequence, internal output variables. So like that, totally four sections are there. Each section is holding different database. Clear? Similarly, the same for whatever may be the element you are modeling in PSCAD. First left half will be holding some different cases. See, so for each case, there will be different database that we should enter. Clear? So now let me explore this source. I hope you understand why we are going with model number 3. Why? Because it only permits the entering of positive and zero sequence impedance. So first the source name. So my source name, let it be by default source one. So base MVA. Base MVA, usually it will be 100 only. So let this value also be stored automatically. Base voltage for ours is 230 kV. Yes, here also 230 kV. Then base frequency is 50 Hertz for us. Then voltage input time constant. This voltage input time constant means how my source is getting started, right? From the source. For example, when you're starting the simulation, at 0.05 seconds, my source will start to generate voltage. But you want my source to generate at my first second, even though turning on the source, my source should generate the voltage at my first second means you can enter here as 1. Actually, this is the default value. We won't change anything. In case if your requirement, if you need means you can enter. So here infinite bus, upon selecting the option for infinite bus means it will be acting like a ideal source where see this positive and negative zero, sorry, positive and zero getting automatically disabled here, right? Upon selecting no, it is getting enabled here. So this is for simulating the infinite bus option. Then here zero sequence differs from positive sequence. Yes. So when means in most of the condition, all my three phase and a single phase, a short circuit current and X-bar ratio will be the different. If all the four will be the same means only my zero sequence and positive sequence will be the same. Other than that, surely it is going to be differ. So I'm selecting yes. If it is not differing means both are the same means if you give no here, it will automatically consider the positive sequence impedance for zero sequence also. But it will be getting disabled here. Clear? So now let me select yes. So after that impedance data format, real and imaginary, as I mentioned now, either in polar form or else rectangular form, you can able to enter. Now it is in rectangular form. So we can also proceed with the same rectangular form. Then graphics display. So it is, there are two views for this three-phase view, single line view. Now let me give three-phase view means for each and every phases, A phase, B phase, C phase, it will appear like this. But if I select a single phase, single line view means the previously. So now from this single line, we can able to connect. Then display details. So this display details is also customized one and will be available for very few elements in PSCAD. Other than that, this display details option won't enable for all the elements in PSCAD. Now let me select no here. See how it is getting changed. All the display got disappeared. Details. No, I want the details means just enable here. Display details. Now it will display. The positive sequence alone, it will get display. Even though you are entering zero sequence also, it will display only positive sequence. KV, Hertz, MVA, and the sequence. So this is the first tab what you should configure, right? So in the second tab, see here, positive sequence impedance, resistance and reactance in terms of ohm. Why? Because we selected real and imaginary. The same for zero sequence also, resistance and reactance in terms of ohm. The same real and imaginary we selected. Then internal output variables is nothing but this is for defining signals. If you want to measure the output power, you can define the signal here. From the signal, you can follow the previous session's process. Signal, defining signal, calling channel, simulating, right, and taking the results. Like this, for entering the output variables alone, there is separate tab. Usually all the elements will have the same feature. For taking the output alone, for entering the output parameters alone, there will be separate tab. Clear? So hope how to configure this, whether it is clear. We haven't entered the values now, up to now. I just explained this model. Similarly, for whatever the model you are using in PSCAD, right? All the elements will be having, as I mentioned before, two halves, left half and right half. Right? The left half will be holding. We can also extend this size also. so that you can see the complete name, right? The left half will be defining the parameters, different types of parameter, and the right half will be defining the corresponding parameters to the left tabs. For example, see configuration positive, zero, input, output. It actually differs, right? The same thing. So is there any doubt? So shall we proceed with the data and do calculation and we can model the source? Yes. Okay. So up to now, this is the data what we have got from client. So after that, we want to calculate the MVA, right? MVA, short circuit MVA. Why? Because after calculating the MVA only, right? After calculating the MVA only, we can able to calculate the positive sequence and zero sequence impedance, right? No, no, for PSCAD functioning, positive and zero sequence alone is enough. Negative sequence is not required, right? So that automation will automatically it will be considering. Zero sequence means what? Whether the positive and zero sequence, whether it is going to yes, whether it is going to change the positive and zero sequence impedances, it is not going to change actually, right? Only the as sign of the value will be getting changed due to the clockwise and anti-clockwise, right? So here upon entering the positive and the zero sequence alone is enough. Most of the elements will be calculated like this only, right? Three phase and the single phase are the same. So for this project, what I had done, this is same only. So here we are not calculating the X by R. X by R will be provided by the client only. We will just use that X by R. Please provide the cheat sheet means. Saravanan, what is meant by cheat sheet? Okay, calculation sheet. Yes, sure. So only I'm doing separate calculations here. So I'm completely performing for enabling and entering all these sheets in the website. Yes. So here, let me show you. So before that, we will be, okay. So first, let me calculate the short circuit MVA. So for that, so first let me enter the MVA base. For MVA base, it is 100. Then let me calculate a three-phase MVA, short circuit MVA, that is three-phase SC. If I'm calculating this, so you might be aware how to calculate the square root of V into I, right? Square root of 3 into, sorry, I missed the 3, square root of 3 into V into I. So 3 into V into three phase I'm calculating. So three phase current. Yes, this MV is for three phase. Similarly for single phase, yes, one in a balanced system, Y is three phase and single phase XPI ratios is difference. So the second option, balanced system. So I haven't mentioned it as a balanced system. Yes, for a single phase MVSC, so just a line to ground RMS into single phase short circuit current, right? So this MVA. So upon calculating this, now let us calculate the actual values, right? Actual values we can calculate. So per unit values, that is not required for us to calculate. So because why? Because we are going to enter here directly only, right? Why we have selected real and imaginary so that it will be in directly we can enter. So eject actual. So eject actual. Let me calculate first for home itself. So after calculating the eject, we can calculate R and X from this eject, right? So how I am calculating this? Yes, all are in kilowatt. No, no, kilowatt. Which one? Which one you are mentioning here? Yes, kiloampere here. Then kilo volt is also there now. So this is MVA only now. Okay, kilowatt where a kilowatt is arising? I'm bit confused. So kilowatt into kiloampere, then MVA only now. No, no, both are in kilo only. See, here it is not volt, here it is not ampere. Yes, of course, Saravanan. That's what I'm saying. This is MVA only. So not at the entering the unit made you confused, right? So MVA only. So this is a basic thing only, right? So is it now I'm going to calculate. Here all the units are in kilovolt and kiloampere only. So directly it will be the value what you are getting is actually a MVA. Clear. So now let me calculate this. Is it actual? So for this is it actual, right? For a three-phase short circuit, you know the formula, right? For three-phase short circuit, whether you know the current formula or else let me type it here. For three-phase short circuit, right? So fault current, how you will be calculating? E by Z1, right? E by Z1. In case if you want Z1 means what we will do is, so E divided by, upon entering equal, it will be sensing as E divided by IF, right? So the same formula I'm going to using here. So in here, IF means line to ground RMS. First, let me complete. Enter. Okay, clear. Thanks, Rabia. No, in balanced system, I haven't mentioned it as a balanced system, Kausik. So I don't know what you are actually saying. So this is the data which we are received from the client itself. So here what you are saying is balanced or kindly reframe or else. So now let me move forward. So for Z, first let me calculate with the positive, right? Positive sequence I'm calculating. So E by considering the line to ground RMS divided by three-phase short circuit current, right? This is in ohms and this is for positive sequence. The same for zero. So this calculations is quite similar to the short circuit calculations of direct format only. So in zero sequence, if I'm coming means zero sequence. So how zero sequence if we are calculating in case of single phase fault system, this itself one phase. No, no. The source will be containing the characteristics of both three phase and single phase, right? So depending upon the system connected or else the fault included, so at the time it will be getting differed. So here it won't differ. Yes. Okay. Let us move forward. Clear. So now, as of now, let me up to completing this. So up to completing this, I'm stopping now the chat option. So after that, we can enable, right? So I think up to this, it will be clear. So then for calculating zero, when calculating zero, this with the help of the same formula, SLG, we will be using, right? With the help of this SLG, how I'm calculating this Z is, let me show you. So the same single phase SLG, this is for a three phase fault and for single phase fault. So this is the basic equations where you might be aware of all these equations. Simply basic 3E divided by, right? Z1 plus Z2 plus Z0. Clear? This is what we will be using. So in further cases, in the approximation, we will be doing right in the simulation part. When doing approximation means we will be considering positive and negative will be the same. So that so my equation will be changing like this. So for the same IF, what I will be receiving is 3E. So instead of Z1 and Z2, it will be turned as 2 into Z1 plus Z0. Clear? So with this, now I want my Z1, right? Because we are calculating, sorry, we want our Z0, right? Why? Because we need a zero sequence impedance. That's what we are calculating now. So to calculate this Z0, I can write the formula as Z0 equal to, so first of all, IF, or else let me bring like this. Let me check IF minus 3 into E. Okay, divided by IF. Clear. So the first, let me consider this alone. So 2 into Z1 plus Z0. Let me bring here completely. So here I will be getting 3 E divided by IF, right? So if I am now calculating this Z0 means, so 3 E divided by IF minus 2 into Z1. Hope you got right. So these are the two formulas majorly we are using for calculating the Is that Z1 and Z0? So for Z0, let me calculate 3 into E as a separate one. 3 into E means voltage divided by IF. Single phase also in this terms it is 50. We cannot say in all our case it will be same. Minus 2 into Z1. Z1 means which is nothing but we had already calculated. Right? So in here, why? Because both the kiloamperes are same. It is appearing as same value. But in case, for example, your short circuit kiloampere, it is quite different means. Just for example, I am entering, it will be changing, right? So in our case, this example, this is the actual value, right? So now from this Z, I want to calculate my R, right? So from this R, I will be calculating my X also. So for calculating my R, so R in terms of ohm only and X in terms of ohm only. So what is the formula? The basic formula you might be aware. Z square equal to R square plus X square. Right? Using this formula upon deriving. Yes, upon changing, we will be getting the equation like we want R, right? So R equal to Z by Z by square root of 1 plus X by R. So this is, we are entering upon converting all these things, right? If you check means it will be we are converting like this only. So using the same formula I'm applying here equal to Z divided by, let me open bracket, square root of 1 plus X by R the whole square. So here we are calculating a three phase. Positive means three phase whole square. I'm closing 0.034. The same for X also. But in this case, sorry, X not. For instead of zero sequence, the procedure is the same. But what we will be using is X by R for single phase, right? The remaining, the Z naught will be the same, right? Why? Because in this case, it is Z1. When coming to zero sequence, it will be Z naught. Then for X, the same formula we can use, the above formula, Z square equal to R square plus X square. So from that, if I want X square means, yeah, sorry, X means equal to square root of X means in terms of positive, Z square. So Z square minus R square. Clear? The same for zero sequence also, Z square minus R square. So here the value is looking quite similar. Why? Because in our terms, it is both the three phase and single phase are the same, right? So this formula also we are using. So now what are the values that we can able to enter in our PSCAD is these two only, right? This R and X values alone we can able to enter here. Let me show how to enter that. So just go inside our source. Already everything is modified here, right? Base frequency, everything. So positive sequence impedance, let me go to positive sequence impedance, resistance, and reactance. So positive sequence resistance is 0.03647. Just copy, right? And just copy and paste here. Control C, Control V. The same for reactance. Control C, Control V. So this is for positive sequence. And for my zero sequence, you should calculate this. Control C. Sorry, you should enter this. In terms of ohm only, we are entering. If you know, I want in a polar form only, magnitude and angle only I'm going to enter means, surely you can enter. So before that, you want to do one thing. In the configuration, you want to change here. The impedance data format, no? You want to change as magnitude and angle. Clear? So now entered all the values, just press OK. Clear? So now values will be appearing like this. Usually positive sequence alone will be shown in detail. Zero sequence won't be observed outside this source. Clear? So now we have modeled the source, right? We have modeled the source. What we should do is we should validate. As I mentioned, no? So elements, everything what we are modeling, we should validate it. Validation means now they are mentioning that three-phase short circuit kiloampere is 50 kiloampere and single phase short circuit kiloampere is 50 kiloampere. So in this, for the same grid, I'm going to inject a three-phase fault and I'm going to inject a single phase fault. So at both the instances, right, I want to check whether my grid is capable of supplying this 50 kiloampere when the fault is occurring. So that is the form of validation here. Clear? So for before validation, with this source alone, we cannot able to validate. We need to add some external parameters. So this third type of source, see here, this voltage and phase angle is remaining open here. It should not be like this. So in order to provide value to this inputs, so there is a specialized option called, see here, in the components tab, data and input or output, this channel like integer constant will be appear here, right? So using this, you can able to place here, just to rotate it and place here. And similarly, another one, rotate it, place here. So it will be by default holding the value of 1. So now what are the value, voltage value you are entering here? That will be alone considered by our PSCAD. Even though if you are entering 230 kV inside this, the value, so if you are entering as 230, right? So this 230 will be considered. For example, if you are entering 400, 400 kV will be considered, right? So in this only we will be able to change the voltage. So let me give 230. Phase angle, let me assume there is no phase difference. So let phase angle be 0. Right? Let the phase angle be 0. So after this, this is the complete model of modeling a source. Right? So now our modeling of source is completed. So including these two also, you must enter. This will allow only integer only. For example, let me show. For example, 230.45 kV if I'm entering. See, input value is not in a recognized integer form. Clear, it will support whole numbers only. So nearer to that, in addition to that, here one option is there now. This one is in blue in color. So this one is real constant. Here you can enter the decimal values, 230.45. Yes, for that two different components. This blue one, mostly we will be using this blue only. Blue one is integer constant. Whereas real constant, if you want to enter in decimal, you want to enter means the next component nearer to this. Clear? So after that, I will be connecting the source to one bus. Let me rotate. By default, it will be in horizontal position only. So you should make it as vertical by rotating. Let me connect this source with the bus using wire mode. Clear? So now I want to measure the everything, right? Voltage and current. So let me use the multimeter in this bus. So after that, everything is ready. Now what we are going to perform? Three-phase fault. Three-phase fault and single-phase fault we want to perform, right? So for that, separate component is there in our master library. Let me go to master library. See, fifth block, breakers and fault is there now. Breakers and faults. So go inside this. Go inside this. See here, there are various components. So as of now, let me pick this alone. Timed fault logic is there now. So you should just copy, Control C, select this timed fault logic. Actually, let me copy and paste and explain. See, actually it is looking like a single component, but itself is a two component. This is a separate component. This is a separate component, right? This timed fault logic is a separate, whereas this three-phase fault component is a separate. But this will work along with this timed fault logic only, right? So using this component only in our PSCAD, we can able to generate the faults. Let me connect this with our bus bar. Clear? So how to configure this now? We have just copied and selected here. How to copy, so how to make it as a three-phase. So first, before that, for two components I mentioned, no. So first, let us explore the component one. So in the left-hand side, there are totally 5. On the right-hand side, let us see the characteristics parameter. Configuration, we are not going to change anything here. Why? Because fault resistance, default, it will be smaller value only. Fault type. So in this, using this only, we can able to change the fault type. See here, in here, what it is showing actually, A to G. A to G means which is nothing but SLG fault. Fault R is getting short circuited and touched the ground. That is the meaning of this A to G. What if I want to simulate a three-phase fault? Then go inside this component, go to the fault type. So change, is phase A in fault? Yes. Then change this also, B also, C also. Is the fault to neutral? Is this fault to neutral? No. Why? Because three-phase fault. Now see that A to G has changed to ABC, which means three-phase fault. So now this component will exhibit the three-phase fault to this bus, to this bus. So this timed fault logic, what it will do? So at what time I should apply the fault and how, at what duration my fault should getting cleared? That I want to know. So let me apply my fault in 1.5 seconds and my duration of fault is 2 seconds, right? So it will apply my fault at 1.5 seconds and my duration of fault will be 2 seconds. So after 2 seconds, you can assume that my system got, the fault got cleared everything. Okay. So now let me run and check whether the simulation is converging or not. Sorry, for this, we want to use build option. I directly performed the run. Yes, it is running. Yes, my simulation completed actually, but we haven't mentioned the call the signal, define the signal, or called the signal, or any channel or plot, anything we haven't captured. So now it is holding the value, but we cannot able to display, right? So before that, before running itself, we want to place the corresponding signals, channels, graphs, everything we want to mention. So up to now, is there any doubt? Let me enable the chat. So up to now, is there any doubt? How to model the grid, how to model the bus bar, everything, how to model the fault logic component. Using this fault logic component only, we are going to create wherever the fault we require in the entire PSCAD. I think you can post chat now. Is that clear up to now? Other types of available to create fault logic. Oh no, this is the only type. Other types means master library will be the same as I mentioned before, no? So this you can configure like this. This simple component can be configured like this and this. And this is for single phase. Single phase, usually we won't concentrate single phase breaker. So only I'm not focusing on this side. This is for our three phase completely. Grid voltage appears as 230. Yes, of course. Why? Because grid is 230 only, no? Then so grid voltage is set to 230 only. Yes, of course. Phase angle is the angle between V and I. Set as 0 now. No, no. Phase angle means like the angle between three phases, right? R, Y, B, like 120-degree we are mentioning, no? That phase difference here, phase angle, phase difference. So here, whether it is 0 means there is no phase difference between three phases. R, Y, B are exactly 120 without any deviation. That's the meaning of entering 0 here. Okay, how to create a SCART connected transmission model on two phase, phase to ground. SCART connected transmission line. Shiva, you can kindly check SCART connected transmission model means what you are actually trying to say. Okay, you can proceed with that. You can post in chat, let me answer. Right. So now, after modeling this, we want to define signals and we want to measure. So let me use this multimeter. So now, what are the things I want to measure? A voltage I want to measure. Of course, yes. Then current, RMS current here we are going to measure. Why? Because the values what we are measuring is the RMS here. If you need means you can measure RMS voltage also, but it is not required. RMS current alone, it is enough for us. So in this, select digital always. Why? Because analog means there will be some disturbances. Upon enabling, select digital. There will be a drop down here. Select digital, instantaneous voltage. Now specify the signal name, instantaneous phase voltage. I don't need line to line. Okay, we can select both the voltage. V phase, V line. So both of them I'm selecting. Then instantaneous current that is not required for us. So IRMS. Let me give the name IRMS. V phase, VL, IRMS. Three signals I have defined. So from the components tab, so using this component, in the previous itself I have mentioned, right? Three signals we want to measure. V phase, phase voltage for V line. These are case sensitive. So usually copy and paste. So after that, use the channels. Yes. Then using the wire mode. Now we can able to observe the bus phase voltage, bus line voltage, and the RMS current. Right before that, I want to pick the graph. So in the channel option, right click on that. Using these graphs, meters, and control, add overlay graph with signal option. So in here also see, now my workspace has got a little bit congested, right? Upon plotting three graphs, it is looking like congested. So at the time, go to view, size, you can increase the size, B, right? So this is the case I mentioned where you can change the canvas settings whenever you need. Okay. Now our simulation space got bigger. Now let me run the simulation. Yes, it is performing. Yes, run completed. So run, let me check. Run completed. Let me reset first. First of all, I should reset. Yes, it is not appearing. Let me show you why. So before that, this build messages is the one another important thing. So where you can able to observe the warnings, messages, errors, right? Only in this build messages alone. Runtime messages also there is another option, but runtime messages will be show the errors which cannot be displayed by the build messages, right? Only runtime error can be build messages can be display the error messages. So as of now, zero errors in my system. So now my system is perfectly working. Then warnings we can omit. So warnings we can omit. And 28 messages is nothing but so beginning the compiling. So started compiling, executing. So like that only the sentences will be. So error only we should mainly focus. Here they are giving the provisions for selecting the error alone. If you want to check the warnings alone means you can select on that alone, disabling these two. Or else I want to check the messages alone means you can check. Usually you should check the errors alone. What are the errors? Warnings and messages, no need. Clear? So now my system is clear, but I haven't got any responses right here. See, so what I should do? First, check with the fault duration. So I'm applying my fault is 1.5. My duration of fault is 2. So totally 1.5 plus 2, 3.5. Clear? So at least I should run my simulation for 5 seconds. But let me check with the project duration. See the duration, it is in default setting. It is 0.5 seconds. So let me increase the duration of run up to 5 seconds. I hope you clear what mistake we have done. Sorry, what mistake I done. So actually total running time it is setting as duration is 0.5, whereas I'm simulating the fault at my 1.5 second only. But PSCAD will run for this 0.5 second. What are the parameters you are giving in duration of run? For that second only it will run. Beyond that, it won't converge. So that the fault is not occurring. So now I have changed it as 5 and now running the simulation. Now surely it will run. Yes. Now it is completed. Now let me reset. Yes, hope it is visible, right? So at my 1.5 seconds, I'm injecting the fault. Three-phase fault I'm injecting. So all my three phases are lying in zero. Clear. This is phase voltage and this is my line voltage. See here, this also during the fault, all my three phase voltages are in zero. Then after the fault, it is coming back to its normal. Clear. So see my IRMS. IRMS, what I should measure? Actually, I should measure 50 kiloampere. Why? Because uh, uh, I'm injecting a three-phase fault. So totally 50 kiloampere I should measure. Why? Because short circuit kiloampere is 50 for me. But here, so before that, let me measure these two. First reset. After that, M measuring. So measure after the post fault. It is 187. And here also measure. Right? It is 325. And if you are measuring here, it is quite low. Why? Let me check. So before that, if you want to give units means, so click inside this channel. There is option called unit here. You need not to configure anything here. So just giving the kV, it will show kV here. Similarly for here also. Clear? So upon giving like this, our graph will appearing like KV. And this is KA. So this 187, I think you might be aware. So 187 only, this is the phase peak I mentioned no in the morning. The same 230, the measured value, what it will be showing is phase peak value. In the phase, it is showing 187, whereas in the line, it is showing 325. Clear how this value is displayed here? 187.794. See here, 325.15. Actually, just now I remember. So RMS option in the multimeter option, this RMS current alone sometimes will won't work. Yes, just now I remember. So only it is showing this bad simulation graph. So for that, what we should do is we should first plot the instantaneous. So from the instantaneous, we can plot the RMS. Let me show you how. Let me go inside the meter. Instantaneous current, let me plot. Let me disable this RMS. So instantaneous, let me give the name as IINS. IINS, let me give. Let me change the name here. I. So this will permit you to give the instantaneous value only. But all I need is the RMS value. So instantaneous value I don't need. So for plotting the RMS value, so there is a to derive this, it is actually containing the three phase value, right? Instantaneous means containing the three phases value. So from this, I want to separate the single phase value means let me use this wire mode and extend this. So there is an option called in the components tab itself. See, array tab like that one option is there. So it is appearing like a pin-like structure. So this name is array tab. Array tab. What this array tab will do is, right? It will classify. So in case if there is three-phase signal means, right? Upon entering the number here, it will classify the R phase signal alone, right? For that, after that, we want to use some RMS block. So RMS block, go to master library, right? In this RMS, meters one option will be there. 13th option, meter will be there. Go inside. So there will be a meter called a single phase RMS meter. Let me copy this. Copy this and paste and connect here. So now it's so in array tab you need not to configure anything. So just go inside the RMS. So always I will suggest the meter to monitor is as a digital one. Why? Because that will provide precise value. Our fundamental frequency is 50. So only thing to be configured is meter type digital, fundamental frequency 50. Right now place this graph value. Now perform the simulation. Let me wait for the simulation to converge. Let me reset. Yes, it is not showing. Or else let me check the 1.52. Remaining everything is correct. Three phase fault only. We are injecting. Let me check for single phase fault. It must show response now. Digital 50 only. Just give me a second. So it is refreshing. So here it is single phase fault. Okay. Okay, or else. Yes, yes, I understand. Yes, we want to plot the multimeter in, sorry, this is the mistake. Yes, now let me check. Yes, now it is, we are getting. So see here. Now, okay, let me come with the three phase fault itself, right? Now let me run the three phase fault. What I should observe is, I think the system getting slow here. So three phase fault I'm injecting, I should observe 50 kiloampere RMS, right? So now it is running and completed. Let us check R. Yes. Now check after reaching the steady state after the fault. It is similar, right? 50.001 kiloampere. So in case if you are feeling that this graph is appearing like a very light, so you can in this option, right? You can select the name of the graph. There will be A. A means at what value currently it is showing. So now if this value is selected, 2 is selected means corresponding to 2 means R, Y, B. So Y's value is showing here. And if you are selecting 1 means R value is showing here. Then V means visibility. If you disable all these three, none of the graph will disable visible. So this is R phase, this is Y, and this is B. Right? Individually you can able to visible, or else cumulatively you can visible. Then B means making it bold. Bold means it can appear a little bit thicker than the previous case. Then M means in case if we are applying any stepwise waveforms other than sine, if you are applying any stepwise means, so at the time you can use this M. That stepwise can be uh, viewed in detail for that M. So in here, let me make bold. So here it is having all the three signals, right? R, Y, B. Whereas here I am measuring only my RMS alone. So R phase RMS alone. Now I make it thicker. See, 50.01 kiloampere it is showing. So how to copy this graph and paste means just click on the graph, right click, copy frame will be there. So copy frame and you can paste here in your workspace or else in your Excel sheet workbook, what you are performing, you can paste here. And this calculation, let me paste here. So 50 kiloampere I am observing and the remaining two, right? Then the remaining two also I want to capture now, Control C, Control V. Direct Control C and Control C V also will work here. 325, I'm getting 325. Then for phase, I'm measuring. Right, phase is 187.794. You can place it like this, one by one. So this is for three phase. Now let me include a single phase fault, line to ground fault. So you can make whatever the phase as a fault. So usually we will check for A only. If you need means you can check B and C also individually. So in this case also, my current must be 50 kiloampere. Yes. After, see, now it is visible, right? Only one phase alone get faulted here. That is R phase alone. In here, you can view in detail. See, the blue one is the R, the red and green is YB, whereas the blue is in zero after the fault. So it is single phase. Here also, now my value is clear. Right? This is for three phase. This is for single phase. So now these two are got validated. Yes. So this is how we should start with source modeling and validation. Right? So sometimes you can ask in multimeter, this RMS option, sometimes it won't work. So this RMS current alone, remaining RMS voltage will work, right? RMS current, sometimes it won't work. So first use the instantaneous. With the help of this instantaneous, using this RMS block and array tab, you can plot like this. For example, if you want to plot for all the three signals means using this array tab once again, and the RMS block once again, and channel must be new. So in this case, upon you are plotting for three phases, you should change this number as 2 so that it will capture the second signal. And here you should change as 3. It will capture the third signal. But for us, one is enough. Calculating in single phase alone is enough, just for validation purpose alone. Right, upon doing detailed studies, so at the time we will be plotting for three phases also. At the time we can use the previous case like. So instantaneous current, if you ask whether it is needed, means it is not needed actually. But if you want to look, that also means you can put a different channel for this. So now interconnect. Now let once again run the simulation. As it is completed. So in this RT1, you can change the name here. IRMS like this. So this instantaneous, let me observe the graph. So after running, if you plot the graph means sometimes see it won't occur. So before running itself, you must plot the graph. Then you have to check with the graph. So let me run once again. So previously I haven't took the graph. Actually, it is a mistake. So after plotting the graph, you must run once again. Yes. Or so instantaneous current is appearing looking like this. All the three phases it is not showing. Yes. Clear. So this is not required actually. If you need means you can plot that also. These three also not necessary. Simply IRMS alone is the mandatory one. Why? Because we are validating this. This voltage level you might be aware. We are going to get this only. Clear. So now in this, so what is how to name the grid or anything means? Why? Because by default it won't appear. But in other softwares, the how to say the element's name will be appearing here itself. Like in the bus, it is appearing like this. But for grid, multimeter, everything, it is not appearing, right? So for that, in the same components tab, there are two different options for us. One is annotation and the another one is sticky notes. So annotations means nothing but it is a, so now let me grid power grid, right? Power grid in the line 2, let me give 230 kV. Now this will be appearing like a text-like thing where you can place nearer to the grid. Clear? The sticky notes also the same where you can type power grid to 230 kV. Clear? It will appear like this. You can adjust the size of sticky notes up to that much you need. But for us, this is enough. So there is two possibility. So similarly, you can name all the components like this. Mostly, I will go with sticky notes. In some cases, I will be going with annotation. So that is depending upon you. Whether you want a clear, detailed view means you can go with this sticky notes. So fonts and the bold option, everything can be included, right? That if you go to this edit property means whether it is a font, at what type of font you should select, whether it is bold or not. Like that, you can go in deep simply. Whereas in annotation, you cannot go anything like that. Just entering, what are you entering in two lines that can be displayed here. Clear? For some of the cases, if for bus, it will be appearing. For this grid, it will be appearing. For some other elements, it won't appear. So at the time, we should do like this. Clear? So this is how we should model the source with the help of this data, and we should validate the source by doing some calculations. Yes, is there any doubt? So 325 means that upon running the simulation only, we will be measuring those values, but we should enter 230 only. Line to line RMS only we should enter. Is there any requirement of 230 kV at source? Ammeter in series with fault? No, 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 no. 230 kV. No, this is actually we are simulating a basic system that is not ammeter, that is multimeter. Does that mean the peak reached more than 80 kiloampere? So from the diagram you're asking? Yes. Due to the disturbance in our system, it goes beyond the peak value of the short circuit IP equal to more slightly greater than 80. But after reaching the steady state, only we want to measure. Then only we can able to check whether our system is capable of supplying the rated short circuit kiloampere. Yes, there are some other tools also. Some other tools means these tools I mentioned. No, this is channel, and this is a rotary switch. This is slider. This is variable switch. This is push button. Clear? So what are the difference between these four? So this is rotary switch actually. So for this, for plotting all these things, this is, you might be aware, this is channel, right? Using this channel, you will be plotting. That is not required here. So these four, for example, I'm using this control panel tab. This is actually a empty tab by default. If you want to control this variable, you can use through this control panels also. So just press on this, select control, drag and leave, right? Similarly for all the things, you can use this control panel. Clear? Now you can understand the difference, right? So what is the difference between these things? So now, see the first one is rotary switch actually. Rotary switch means we can fix the position of this switch anywhere. See, 2, 3, 4, 5, 6. So for that each position, what action to be performed must be set by you. See position one data. For this, if I'm, for example, for my position 5 is holding 525, anything, it can be a kV or anything, just for reference, or else 400 kV is there means. So now I want to supply 400 kV means this position you can adjust like this up to 5. 5 means here it is showing the value, right? 400. This is rotary switch actually. You can able to set up to 10 values here. Yes, maximum 10 only. Then the second one is variable. Variable means precisely if you want to model. For example, go inside this variable. You can set the maximum and minimum value here. Right? Maximum value, let me give 10. Minimum value, let me give 0. Initial value, let me give 1. Now see, 0 to 10, it will be appearing. You can adjust in a fine manner. For example, if you need 5.5 means also you can type 5.5, right? So this difference between this and this, I think you might be clear. Then this variable, this is known as two-state switch. So either it can be turned on or turned off. If it is off means it will be in 0, on means it will be in 1. Then this is a push button, right? Push button, where upon pushing it once, it will see, upon pushing it once, it will give the value of 1 to the network. So it can be used wherever we need, right? This is also a user defined component only. So we can use in order to adjust anything. Right? So these four are the other tools here that are present here. So that scenario I mentioned, no, that scenario will be suitable for this. Let me explain that. See, for this is first scenario. So for this, let me change some values, 100 to 100. So I haven't connected it with any systems. So I'm just 1000 is there. So for me, I'm setting here as 700 here, right? In here it is 5.5. Now I'm turning off the switch and my push button, it will be by default. See, when the button is pressed, not pressed, it is 0. When the button is pressed, 1. Similarly, we can change. So now let me save this scenario. See, save this scenario first. This action will override the value stored in the active scenario. Proceed with save. So you should not alter the base thing. So just cancel, sorry. First of all, you should select this drop down. So go with save as. So in the save as, just give me case 1. Okay, clear. Now change the values as 500. So this scenario will be saved. See, the first scenario will be saved. I think I had already, some of the scenarios are there. No, no. So only case 1, yes. Now let me save the scenario into case 1. So now let me view the scenario 5.5, 0 to 10 I had given, no? Then 0, 0, this 3, 1. In the variable is this I think it might be visible now. See this case 1, this 4 are saving our values. So 5.5, here it is saving. 6, position 6, see here, it is saving. And 0 to 1, it is in 0. And this is when pressed, it is 0. So when the push button is not pressed, it is 0. When it is pressed, it is 1. Okay. Now for the same, I'm changing the values. I'm changing the values here. Let me come to 3 and let me go to 7.7. So now let me turn on this and let me configure here as when the button is not pressed, it is 0, 1, and the button is pressed, it is 0. Clear? So now let me save this scenario, save as case 2. Case 2, yes. So now in this active scenario, we can check case 1, case 2. Now we have selected 307.711. If you select the case 1 means your own previous values will be occurred. See here, 600, 5.5, 0, 1. Whereas in my case 2, 300, 7.711. The base means very basic, the first thing, without altering the base. If you are using this scenario option, always go with without modifying the base. So just click save as and create it as a new case and save so that you can able to view the cases here. Hope it is clear, right? So in case if you are using this specialized components and their values must be changed for each and everything means you can create some scenarios like this. Clear? So let me come to the base first once again. If you view the scenarios means it will be like this. Why? Because we are having four things here. So base also having four, whereas my case one also having four components, case two also having four components. If you don't need any component means you can select here and delete. Clear? So this is how you should use the scenario. So this components will be used, right? We can see in, so for disabling and enabling, just select all those control D for disable, control E for enable shortcuts. If you want to disable this element individually means just select on that element. The same control D means disable. Control E means enable. You can use the shortcuts also. Yes, is that clear? Logic gates will be used in integrated circuits, ICs. Whenever we are modeling with electronic components, we will be modeling. But for our power system, we will be not using any logic gates. Right? So is there any doubt in this? Okay, now let us just quickly model. Let me open the another case file also with what I created in the morning. Yes. So this is for our SLD creation. Let me show how to create an SLD. So let me enable the grid options. Report creating option is not there. So only dot out files can be exported here. Like PSCAD excellent report cannot be generated here. Right? So we should want to capture the corresponding cases results only, like the graph or else in the form of table like that. 18 cases I mentioned, no, that is for installation coordination, not here. In the installation coordination, when you are performing with TOV, right, temporary overall study, according to that IEC 60071 Part 4 standard, we will be creating all those cases. But for this basic session, we cannot able to create some just basic cases only I'm creating here. But that will be logical cases like Ferranti effect separate case, load rejection, LG fault, LLG fault, LG fault with the load rejection, LLG fault with the load rejection. So like that, there are various cases, right? That will not be included here. So how to create the SLD is just copy the same source from here. So after validating, you can use the source wherever you want. Clear? So just copy. I'm just copying here. See, I'm just selecting the source alone. Control C. And I'm pasting in the new workspace. Control V. Clear? So now let me connect with the bus. So after that, let me connect with the transmission line. So for transmission line, let me show you. So when coming to PSCAD, so scenario creation, view or delete or create scenario. I think you might be aware where to use scenario. Then when coming to transmission line and cable model for both transmission line and cable model. So there are two approximations here. One is pi section and the one another one is distributed parameter. Let me show that. Where is the word? Yes, here it is. So this comparison on flowchart will be there. Let me show you. Yes. Right. So this is for modeling of transmission line and cable. So here modeling techniques will be classified into two different types. So one is pi section and the another one is distributed parameter. So in the distributed parameter itself, it can be classified into two. One is single frequency and the another one is frequency dependent, right? In frequency dependent, it will be classified into further two. One is model domain and the another one is phase domain. So what in this modeling techniques, we will adapt only two. The first one is this pi section and the another one is frequency dependent phase domain, right? FD phase model, frequency dependent phase domain model we are mentioning. So other than that, Bergeron model is there. So these are a specialized thing in our PSCAD, which will permit you to model the exact transmission line or cable, which is as like in the field. Whereas this pi section is the approximate equivalent model. Whereas you can enter only the length and the RXB parameters alone. Other than that, you cannot able to enter anything, right? Whereas in our FD phase domain model and Bergeron model is for only single frequency, and this will be used for GIS components, right? Gas insulator substation components. Whereas this FD phase domain model is the detailed network where you can model the entire transmission tower, transmission line, the length, the conductor properties, everything you can able to model here. But so for time concern, I will be modeling as a pi section here. So for pi section, for transmission lines here it is. So if you go inside this transmission line means it will take a long time to complete. So now let me go for pi sections. Go inside this. Let me copy the first one. This is another one, two circuit pi section. For us, single circuit pi section is enough. So pi section, let me paste here. So similarly, we can adjust the shape of the appearance here. Go inside this. So it is in compact view, three-phase view, single line view I can give. Right, single line view, it will be appearing like this. If you want compact means you can give like that. Clear? So now let me enter the RXB parameters. This line name, this line name is for your reference only. If it want to appear in outside means you want to use annotation tool. Let me enter RXB. So mostly whenever you are using the transmission line or cable parameters, always go with RXB parameters, which will give you the precise modeling as well as in answers. Results also per unit value, RXB per unit value. Coupled, my frequency is 50 Hertz. Let me enter the line length as example, I'm entering 100 meter. Then RXB, my rated voltage is 230 only, right? So as of now, let me proceed with this default values. Why? Because my default values is also for 230 kV only. So if you need another bus, go to the components, bus, rotate it. So after that, we want to one transformer, right? Let me go inside the transformers in the master tab, navigate to master, go inside this transformers. Let me select the three-phase two-winding transformer, Control C, and in the case, let me place here. Clear. So once again, another bus bar. Let me consider it as solidly grounded. So from here, you can able to pick the ground. In the component itself, you can able to pick the ground and place it in the star. So solidly grounded. So 60 hertz, not 50. Sorry, 50 hertz, not 60. 230 bar, 11 kV. For example, I'm giving 230 bar, 11 kV. Clear. So here also transformer display, we can able to display details, right? Right. So after that, let me connect all these things. So finally, let me connect any loads in order to check. So loads, it will be available in passive elements. Upon scrolling, see here, single or three-phase loads is there. Let me copy and paste the loads. So for both three-phase and single-phase, we are placing this loads only. This load have the capability of sensing automatically, right? So in case for that, we want to enter the per phase values only. That is the only thing. See the rated voltage, RMS LG. So this is 11 kV. So for line to ground RMS, let me enter for where it is. The same thing, let me enter. 6.35085. Let me copy. Line to upon entering line to ground RMS, it will automatically sense. I had copied, right? I haven't copied. Yes, so upon entering like this itself, it will automatically sense as a three phase. So upon where we are connecting, it will act as a three phase. Where we are connecting it as a, it will act as a single phase, right? So now let me run the simulation and try to. We haven't plotted anything. We haven't plotted anything. So let me plot the current from here. The same thing. So after that, voltage at the two different buses. For the, if you are plotting voltage alone means you can use this component, right? And the another one. So finally, yes, these three if I'm measuring, for example, I'm taking. So IA underscore one. So first we should define the signal for plotting. Then EA underscore one. Then the same EA2. So control C and control V. I'm copying the signal, previous signal and rename, just rename. So finally, let me choose the channels. Let me plot those channels also. Then after plotting the channels, next step is to bring the graph. So canvas settings is not enough. So I am changing the canvas as A to B, that is A4 to A3. Clear? So this is how you will be developing. So now let me run the simulation. So before that, we haven't used the build option, right? Now let me use the build. So build is nothing but in case any error messages that we need to correct before running means it will show, or else it will show like this, finished compiling with PSCAD version. So upon showing like this means our system is ready to run. If it is not ready to run means it will show what type of error we are done in our network. Yes, it is asking, yes, the simulation completed. Now let me reset all the graphs. So we haven't created any events, right? So in the sending and also let me place one voltage so that at least for a current effect, let me explain you the same thing, right? Instead of the CA2, can give EA3 plot a graph. So this graphs you can place anywhere in the network, and it is not mandatory that all the signals and the graphs must be placed nearer to each other. So signals you can place anywhere in the circuit. Similarly, the graph also. Clear? So now let me run the simulation. So here EA1 is sending in bus, EA3 is receiving in bus. Yes, we are receiving something. So in order to check whether our model system is perfect, so just to disconnect the load and increase the length as, how to say, 400 kilometers. Yes, upon entering 400 kilometer, let us check the Ferranti effect. Okay, year two. Okay, including the transformer is not working here. Yes, let me check then year one and year two. So it is showing in, as I mentioned before, per phase value it is showing, right? The year one is sending in, whereas measure 206. So if you want means you can plot for RMS also. So for that, let me bring this RMS. RMS not be same. The same case for receiving and also let me proceed. This is EA2 signal. So before running the same signal, so disable the other signals that are in the same name. So sending and receiving. So this graph is not required for us. Why? Because now we are plotting sending and receiving, right? So once again, I'm placing new graphs. Let me run the simulation and check. 230 kV only, but slightly higher than this is 133.2. Then if you are measuring here, here it will be 146.7, right? So why? Because we are entering the length of this transmission line component as 400 kilometer. So it is showing this sending and receiving and like a variety effect like distortion here. So RMS block, it is observed in, if you go to master, in the meters, right? 13th tab in the top, single phase RMS meter. We can find this RMS meter here. Then, perfect. Stray capacitance, usually we will model during our switching and lightning study while performing installation coordination. So for this basic model at all, we will want model the stray capacitance. Which equipment to have stray capacitance? Usually transformer will have that stray capacitance, and we will be modeling it for insulation coordination studies. Other than that, remaining elements that stray capacitance, we will not be present here. So using the same component I had shown previously, no? Same component, you can able to create all types of fault, right? So SLG, LLG, triple L, everything you can create here. Yes, power factor correction capacitors. No, those are capacitor banks, right? That is not equivalent to stray capacitance. Power factor correction capacitance means that is capacitor banks that will be modeled separately. What Ayush is asking is stray capacitance. You can go ahead, Pradeep. Sorry. Can you please explaining how to perform two different PV inverter parallel operation simulation as we are observing disconnect after some hours of operation? So Niket, actually PV inverter, everything is most advanced topic. So ours is basics of PSCAD session. Yes. So if I start explaining that things means it is not fair here. Power factor correction capacitor banks are available in master list. So in PSCAD, modeling the basic capacitance is enough to model it as a power factor correction capacitor, right? There is no specialized tool for power factor correction capacitor at all. Directly, we will be modeling the capacitor. Before that, we will be validating that capacitor. That entire network we will be validating, and we will be proceeding with our network. Yes, I think I'm done now. So is there any doubt up to now what we have seen? So starting from the what is PSCAD, why is PSCAD? So everything I hope you have got some idea regarding how to create a new file and what are the types of files, files classification, .pscx, .pswx, .psmx, everything. Then after that, we had came across this ribbon control bar, right? We have explained all these elements in the ribbon control bar, right? How to clean up the model, how to create a scenario, right? And after, before lunch, we have done with how to plot the graph, right? How to call a signal, define a signal, how to call a signal, then how to connect it with the graph, and how to look the results, everything. Then finally, we started the source modeling with the data. So with the source, I showed how to model the source and validate the source with some calculations. And we have validated the same in our PSCAD also. So after that, we have created a simple SLD network. So this is like we should configure everything in PSCAD. Yes, I'm done. Is there anything you haven't understand anything or else? Yes.
Yeah, good evening, all. I guess, hope you had a great session. Can you just put up, just a one word about today's session? I will answer a few questions which is there in the chat from Rabia as well as Newton. But before that, want to say, like, at least one word about this. Yeah, thank you so much for birthday wishes. All right. So actually, to say why we have planned this session is because there are many requests which came from the participants to uh, do a course on PSCAD at an affordable price. So that's the real reason why we have done this. Unfortunately, I couldn't join, but I guess Pradeep has done a decent job. But at least technically, you have to understand the difference between the general simulation software. When I say general power system simulation software, RMS tools like PSSC, ETAB, SKM, SIME, EC Power, XR, like any power system, Aspen, like any power system you call it, versus an EMT tool like a PSCAD and EMT-PRV. Right? If you're performing a short circuit studies using an RMS simulation tool like ETAB or PSSC or Aspen or EC Power, you will not be able to dictate the instant at which the fault occurs. Based on that, your DC component changes, your peak asymmetrical current changes, etc. Because the objective of that software is to just to find out the switchgear rating, so they need just a worst case. So whatever the simulation which you're doing it in ETAB will not really uh, match with the real time faults or whatever it is. So when you have some ComTrade files from the disturbance recorder, and if you do the same simulation in ETAB, they will not really match. So then means to say what is PSCAD or what is EMTPRV they are doing? They are probably to say providing you an option further in a detailed model. So which means if your objective is to perform load flow to find out the voltage drop or losses or equipment loading or OLDC range, go with the general RMS simulation software. If your objective is to perform a short circuit studies to find out the switchgear rating, go for a general power system simulation software. If you want to do, say example, relay coordination or plus studies, go for a general power system simulation software. But if you want to do a post-mortem analysis of a real fault with a ComTrade file from the disturbance recorder, then you have to think of PSCAD. If you are doing a transformer energization study, you have to go for a PSCAD. If you want to do an analysis on the renewables, where like the switching frequency of this inverter based renewables is in megahertz, so your time step has to be in microseconds. So whenever you want to do some dynamic study with a time step in microseconds, then general RMS simulation tools will not helpful, where you have to go for an EMT tools. So that's pretty much like, I mean, what to say, you have to understand. So means what to say, where PSCAD is used. If you want to perform an insulation coordination study with a temporary over voltage, slow front over voltage, which is a switching over voltage, which I can call like transformer energization, line energization, cable energization, reactor energization, line re-energization, etc. Or uh, lightning over voltage, which is again direct stroke or backflash over, very fast front over voltage in gas insulated substations, ferro resonance, transient recovery voltage, subsynchronous resonance. So all those things like you can do only with the like EMT tools, which means either PSCAD or EMT-PRV. These are the only two tools which are available. So that's an insulation coordination part. Second one, like means to say growing renewables, now inverter-based renewables, which is wind, solar, and even like I mean to say energy storage system, which is battery energy storage systems. Like though you perform the studies in an RMS tools like PSSC, or even if you are performing in Dixel and Power Factory, nowadays almost all the utilities are started asking validation with the PSCAD. So the first application of PSCAD is insulation coordination. Second application of PSCAD is grid compliance studies for renewables, which includes battery energy storage systems. Third one, like I mean to say protection. As I talked about, like if you are importing ComTrade files and if you want to like if you want to like I mean to say validate with the real-time scenarios, then the PSCAD becomes inevitable and unavoidable. And beyond it, if you're performing a transient stability studies, probably if you want to model your generators in detail, or if you want to do a motor reacceleration studies, or if you want to perform the short circuit studies with an IS limiter, or if you want to perform the studies like fast bus transfer, looking at like how these motors are reaccelerating. If you want to do some grid islanding studies, this is all like where the PSCAD application comes, which supersedes the basic capability provided by RMS simulation tools like ETAP or PSSC. And coming to the next, where this PSCAD supersedes all other general tools is its ability to like get the whatever the converter control system which is inside, which can be probably like I mean to say modeled in PSCAD, which is not really possible in other simulation softwares. So what I mean, before the relay is I mean to say given to the market, the OEM will test their behavior using a digital signal processing model development in PSCAD environment. Similarly, like I mean to say, a solar inverter or a battery energy storage system like bidirectional converter or a wind turbine generator, double fed induction generator, they do the field measurement and probably they will develop a PSCAD model and they benchmark both and probably they compare the behaviors, because this like means you cannot test each and every events in the physical, but you can test it each and every activities in the simulation. That's where the PSCAD helps, where like the conventional tools will not really be helpful. So can you do something similar for Dixcellent and PSSC for beginners? Satya, like for PSSC, which is already there, you can reach out to Malati. And Dixcellent Power Factory, definitely we can think of something like this. PSC is used for steady state, fault study, dynamic studies in wide areas. Surrounded, like you're right, PSSC is used for grid level studies, like where the entire country is modeled, or probably like I mean to say, performing low flow short circuit and basic RMS dynamic studies. Is there any offer or planning for a PSCAD advanced session? I will come to you at the end, maybe in another 5 minutes. Good session. Thanks. Please share the recordings. Recording will be available for you. Recording of this for a lifetime will be available. Do not worry about it. Definitely very affordable price. Thanks, Saravanan. Like means to say similar way. Like means to say if you want a PSSC, we have done already. So that recording you can collect it at affordable price. And excellent, definitely we can think of maybe Maldi. You have to make a note of it. Good for beginner. It was completely new for me. That's great, Newton. Good kick start. That was great, really helpful, really informative, new level, useful and good insight. Beautiful session. Thanks, Alok and Power Projects. Thank you, Manikantan. Nice presentations, fantastic, and the correct speed. It's knowledgeable. Belated happy birthday. Thank you so much, Ibrahim. Very informative for beginners. Power Factory and PSCAD same or how much it is different? Power Factory is good for again like basic load flow short circuit like I mean to say RMS simulation studies. To an extent, they have a capability on the EMT, but when it comes to the insulation coordination or renewable integrations, grid compliance studies, obviously PSCAD, like I mean to say, is much better than a Dixcellent Power Factory. Or Dixcellent Power Factory, what their simulation which they are doing, they will benchmark with the PSCAD. Can you tell me how many pulse inverters can be modeled in PSCAD? Ravia, its choice is yours. Like, I mean, there is no limitations in the PSCAD. You can develop your own model with how many pulse which you want. And like nowadays, nobody is going for like increase in number of pulse, but instead they are going for a pulse with modulations. Can PSCAD be used to study data center faults in rack PDU? To let you know, like my suggestion, like means say for data center, like rack level or PDU level, like means not studies. Like I still recommend you to go with the conventional softwares like ETAP. Yes, sir. And like you can probably reach out to Malati. Malati will give you for a PSSC. Malati, I guess like I mean, so a PSSC, like you can share like that link, which I guess like we have done some times back. Maybe few people joined. Or like know about power projects a little late. I guess like PSSC, like we have done about 6 months back, the like base level course, something similar to this. Would like to get basics to do task or model similar to case. So more practice follow up in the WhatsApp group or mail. Definitely Newton. Thank you so much. Probably we will meet for some business in the upcoming days. You're most welcome, Sanjay. All right. Uh, to an extent, like I mean, so say I am done on the technical session. So if you want generic dynamic modeling will be good in very large grid excellent. Is it same with the PSCAD? Uh, PSCAD will take a lot of time because the time step is very small and probably like I mean to say time to simulate is more. But like countries like Oman, Australia, they're performing like country level PSCAD dynamic studies, Ibrahim. That's probably like I mean to say looking at even taken India. So India, like means to say, solar alone we have more than 100 gigawatt. So like means to say renewables, if you look at the installed capacity, it's approaching about 40%. And battery energy storage system is growing like anything. So considering all, like means to say country level PSCAD simulation becomes inevitable and unavoidable in probably like means to say near future. And I'm just going probably a step ahead. Beyond PSCAD, people will be looking for hardware in loop HIL studies or even like RTDS, real time digital simulators, which is like RTDS or Opal RT can do. So that's probably like means to say next step forward. Like means to say originally we have started with some basic simulation software for low flow short circuit, like maybe ETAP, PSSC, like means SKM, SIMA, etc. Then we have gone to MTP simulation. Then the next step is hardware in loop, and the final step is like a real-time digital simulator. Ibrahim, that I guess like that answers your question. Yes, just put yes in chat.